Hello everyone, welcome to the session and welcome to my channel Aptitude Club. So this is the second session of the Reminders series. If you have missed the first session, I'll pin the link of the first session in the I section of the video. You can check it out. And started this Reminder series looking at like the complexity of the numbers area. So if we can cover this one portion properly, then a lot of like burden reduces. So numbers portion is very vast, and a lot of students find it difficult to actually get hold of this area. So what I'll be doing is I'll break the numbers part into different portions, and we'll take up as different series. So we'll get some more time to adapt and learn the concepts, going to the depths and solve more questions to be able to analyze what is the difficulty of the questions and why do the questions become difficult, and when to solve a question and when not to. Okay, because end of the exam, when I say this is an easy question, this is a difficult question, that is something like maybe if I have solved so many questions I can tell, but when you are sitting in the exam and you'll have to actually decide, it becomes a little tough in that case. So that is the purpose of like breaking down and just starting with the reminders series. Once again, I'll say that anyone who is just starting their cat preparation right now, you can start with reminders, like understanding of reminders. Don't worry too much that why reminders and starting with reminders. I hope you would be starting with other areas also, arithmetic and all once we start kiye hoge. But if you are watching reminders, I hope this will definitely help you understand and enhance your concept clarity on this portion. The first session was on basic remainder theorem, and we saw that what the theorem is all about. Two clauses: remainder of a sum is sum of remainders, and remainder of a product is product of remainders. That means remainders are additive and multiplicative in nature. And how questions are solved using that theorem. Okay, what is the application? We took some examples and we saw that there's more to it. Gradually, once we go ahead in the series, I'll get to complex questions and you'll see that if you understand, then it's not difficult. Reminders एक ऐसा area है जहाँ पे any question you can solve in 30 seconds. So that's the big advantage of the reminders portion. So gradually, once you cover, you'll get to know. Don't worry too much. Let us go one step at a time, and I assure you, if you watch the total reminders series end to end, you will definitely find reminders questions easy. 99 to 100% of the times, you will solve the questions in less than a minute. Okay. So if you are new to the channel and you like the video, do share and subscribe to my channel. This is a new channel that I have recently started. So if you do like my way of teaching and you find the concepts helpful and you understand them properly, feel free to give a feedback in the comment section also, and do subscribe to my channel. Okay, so without further delay, let us start. Fermat's little theorem. Today's session will be on the second theorem. Yesterday we had this the first theorem, basic remainder theorem. Today we'll be doing Fermat's little theorem. So what is this theorem all about? First, the definition, और ये theorem का statement क्या है? Fermat's theorem says for any number a, O prime to p, remainder of a to the power p minus 1 when divided by p, a to the power p minus 1 when divided by p is 1. Okay, where p is a prime number. This is important. Where this p is a prime number, the number has to be prime. That means the divisor is prime. Wherever the divisor is prime, I can think of applying Fermat's theorem. A simple example would be this: the remainder of, let us say, I'll say 12 to the power 6 divided by 7. The remainder is 1, because this is the prime number p and 6 is in the form p minus 1 and 12 and 7 are co-prime. What is the meaning of of co-prime? If you would be hearing this term for the first time, two numbers are co-prime if their HCF is 1. Two numbers are said to be co-prime if their HCF is 1. That means they have nothing in common except 1. There is no other common factor. Only 1 is the common factor. Then the two numbers are said to be co-prime. So Fermat's theorem very simple. If the divisor is a prime number and वो number ऊपर जो है dividend में उसका power, if it is p minus 1, so remainder of a to the power p minus 1 when divided by p it is 1. Very simple theorem to use. But questions कैसे आएंगे इसके? Let me elaborate on this example. Suppose it will say find the remainder when 12 to the power 26 is divided by 7. Find the remainder when 12 to the power 26 is divided by 7. The moment you see 20, यहाँ पे 7, so you can see, okay, using Fermat's theorem, if I use Fermat's theorem, I know that remainder of 12 to the power 6 divided by 7 is 1. Of 12 to the power 6, I know what is the remainder, but what will be the remainder of 12 to the power 26? How do I reach there? So this is where basic remainder theorem will be used. 12 to the power 26, as I said in the previous session, I've linked the session in the I section. So I button पे click करके you can watch the previous video. Basic remainder theorem is the foundation of all theorems, and at the end of almost all questions you will come across basic remainder theorem in some way or the other. What I'll do is, I know the result for 12 to the power 6, but I'll have to find for 12 to the power 26. So how do we do that? So I'll break 12 to the power 26 as 12 to the power 6 into 12 to the power 6 into 12 to the power 6 into 12 to the power 6. So it becomes 24 into 12 into 12. This divided by 7. Now this essentially is a product. Now individually, if I calculate the remainders, 12 to the power 6 divided by 7, here the remainder is 1. Again the remainder is 1. The remainder is 1 here, and यहाँ पे 1. 12 divided by 7, remainder is 5, and here it becomes 5. And because remainder of a product is product of remainders, so I can write this as 1 into 1 into 1, ये सब multiply हो जाएगा. So remainder of 25 divided by 7, and 4 is the final answer. Such an easy question. I am using this principle, remainder of a product is equal to the product of remainders. Please watch the previous session if you haven't, so you'll find these questions more easy. Okay, definitely it will be easier, because if you don't know the principle, maybe थोड़ा अजीब लग सकता है ये क्या मैं किया. But if you know this principle, remainder of a product and product of remainders, very simple way I have explained. So please watch that previous video. You'll find these type of questions very easy to approach. So we saw here that I'm using the result of 12 to the power 6 to calculate the result for 12 to the power 26. So what did Fermat's theorem do? Essentially what Fermat's theorem is doing here is from 12 to the power 26, the problem basically reduces to these two 12s. बाकी ये जो 12 to the power 24 था, इसका तो कुछ फायदा हुआ ही नहीं, because if 12 to the power 6 में remainder 1 आ रहा है, 12 to the power 6 into 12 to the power 6, 12 to the power 12 में remainder 1, 12 to the power 18 में भी remainder 1, 12 to the power 24 में भी remainder 1, or any multiple of 6 I take, the remainder will be 1. So what Fermat's theorem basically does is it reduces the power of the dividend. From 12 to the power 26, the problem reduced to only 12 to the power 2. Now this is easy to calculate. 26 looks like a bigger number, but 12 to the power 2 is now easy to calculate. The purpose of Fermat's theorem is to reduce the power and make it a smaller number, and then you can apply basic remainder theorem and solve. There are multiple ways to solve this, but मैं initially ऐसे start कर रहा हूँ. धीरे धीरे आगे जाके you'll see there are multiple ways to approach. So we can generalize it in this way, that if remainder of 12 to the power 6 divided by 7 is 1, it is same as remainder of 12 to the power 12 divided by 7. It is same as remainder of 12 to the power 18 divided by 7. Remainder of 12 to the power 24 divided by 7, and so on. So in general I can say any multiple of 6, remainder of 12 to the power any multiple of 6, let us say 6k I'll write, where 6k indicates a multiple of 6. So this tells us the second part, or it's like an extension of the Fermat theorem. This is the parent theorem, part 1. Part 2, that remainder of not just p minus 1, rather any multiple of p minus 1 भी होगा तो remainder is 1 where p is a prime number. So you can use this the next time rather than writing individually. You can like shorten your calculation by that. For an example, इसका example देख लेते हैं. Suppose I'll say find the remainder of, let us say 18 to the power 47, 18 to the power 47 divided by 47 ना लेके, let us say 18 to the power, let me take it as 51. 18 to the power 51 divided by 13. So I'll break it in this way: 18 to the power 48 into 18 into 18 into 18. This divided by 13. Because if 13 is there, तो ऊपर पावर में 12, या तो 12 के में रिमाइंडर 1 आएगा, या तो तुम्हें पावर 12 चाहिए, नहीं तो any multiple of 12. That is why I took 18 to the power 48. So I can directly say 18 to the power 48 में remainder is 1. And every time 18 is divided by 13, remainder is 5. And remainder of a product is product of remainders. So you get 125 divided by 13, remainder is 8. Makes sense? Very, very, very easy question. Okay. Let us see another example. Very simple theorem, very easy to use. You can take examples on your own. बस mind में ये रखना, the number has to be prime. Suppose it is saying find the remainder when, suppose let us say 25 to the power, let us say 63. 25 to the power 63 is divided by 11. So 25 to the power 63 divided by 11 करना है. So in what way should you split this? You will write it as 25 to the power 60 into 25 into 25 into 25. This divided by 11. So 25 to the power 60 में remainder 1 आएगा because the divisor is 11. So if you have 10 or any multiple of 10 in the power, then the remainder is 1. And every time 11 is divided, 25 divided by 11, remainder 3, 3 and 3. So ये multiply हो जाएगा. So I get remainder of 27 divided by 11. You keep dividing until the remainder is lesser than the divisor. If the remainder is greater आ रहा है, वो possible नहीं है. Always keep in mind that remainder is always lesser than the divisor. Always. This has to be always maintained. तो 27 अगर आ भी रहा है बड़ा, फिर से डिवाइड कर लो, and 5 is your answer. So likewise, you can break complicated questions and solve it in this way, and such a simple theorem to use. Okay, very easy questions. And you think about this, exam में ऐसे questions अगर आते हैं, how much time you should take? 30 seconds से ज़्यादा लेगा ही नहीं, एक ही principle है, and आराम से solve कर सकते हो. Just mind में you have to understand the principle of the remainders in a proper way. Then the game becomes extremely simple. All right. Let us see a few questions. First question यहाँ पे. If you would be watching this video, pause the video, try this yourself and then look at the explanation. ठीक है? So it is asking find the remainder of 53 to the power 53 divided by 17. So the divisor here is 17. That means either 16 or any multiple of 16 में remainder 1 आएगा. So I'll break it in this way. It is 53 to the power 48 into 53 to the power 5 divided by 17. Now this 53 to the power 48 में remainder 1 आएगा. So I'm only left with 53 to the power 5. So it's like writing 53 5 times. तुम ऐसे 5 बार लिख सकते हो, नहीं तो एक बार में जो रिजल्ट आएगा 5 टाइम्स में भी वही रिजल्ट आएगा, तो बार बार नहीं लिखना है. Now, every time 53 is divided by 17, the remainder is how much? When 53 is divided by 17, 17 is 51. So remainder is 2 in each case. And again it's a product. So remainder of a product is product of remainders. 2 multiplied 5 times, I get 32, which is again greater than 17. तो आंसर कितना आ जाता है 15. Such a simple question to use. Very easy theorem. I hope all of you are getting this. And end में देखो वही आ रहा है, remainder of a product is equal to product of remainders. An alternate way तो नहीं है, just a different way to write this. The moment you get this 53 divided to the power 5 divided by 17, what you could have also done is 53 को 17 से divide कर लो, remainder आ रहा है 2, तो 2 to the power 5 divided by 17, ऐसे भी लिख सकते हो. So 32 divided by 17, answer is 15. You can write it in this way also. Meaning is same. 53 को 5 times क्यों लिखे? I can shorten my writing. उसको कम कर सकते हैं by writing it in this way. I hope all of you understand. जैसे जैसे आगे solve करते रहेंगे questions, you will not have this necessity to write. Automatically you will eliminate the steps. Initially just try and understand. A lot of you देख के भी बता सकते हो, but जिन लोगों को थोड़ा difficult हो रहा है process करने के लिए, please don't worry. आराम से लिखो, one step at a time. Write every step. Understand how this principle works. एक बार वो समझ गए, then you can catch it up very soon. Okay? Don't worry about speed. Focus always on understanding of concepts. Okay, don't get too much objective that I'll do this and I'll read this, I'll not read that chapter is important, this chapter is not important. All those things will make sense once you have understanding of the chapters. If I don't understand a chapter, then I am at no position to decide whether it is important or not. And if your aim is to get a 99 percentile, which I think all of you would be aiming for, nobody should aim for a 90 percentile. मैं ज़्यादा optimistic positivity, I'm not asking you to I'm not advising this in the way a motivational speaker does. What I feel is when you are preparing for a competitive exam, you should always try and achieve the best. If you aim for a 99 to 95 तक पहुंच ही जाओगे, but 99 वाला attitude लाना है, that I'll understand, because your competition is in that scale. You cannot afford to be complacent and be selective beforehand. The exam is about selection. Because when you sit in the exam, you will have to identify the right questions, easy questions, and then solve. But वो exam day पे करना है, उसके पहले से तुम अगर selective हो गए, ये पढ़ूंगा ये नहीं पढ़ूंगा, that's a dangerous road to work on. And decide yourself that should I solve these questions or not. These are very easy questions, so why not? Why not? I'm not asking you to spend a lot of time in this, but especially if you are interested that you will get a good hold of the quants portion, you will definitely enjoy these concepts. Okay. Let's take a look at this one. Find the remainder of 19 to the power 19 into 26 to the power 26 divided by 7. Again look at this, the divisor is 7 here. So if I have any multiple of 6, then the remainder will be 1. So I'll break it in this way, it is remainder of 19 to the power 19 divided by 7 into remainder of 26 to the power 26 divided by 7. 19 है, so I'll write it as 19 to the power 18 into 19 divided by 7 and 26 to the power 24 into 26 into 26 divided by 7. बस इतना स्प्लिट कर लिया, अभी एकदम इजी. This remainder is 1, 19 divided by 7 remainder is 5. This remainder is again 1, 26 divided by 7 remainder is 5, and this is again 5. So I get 5 into 5 into 5. 3 बार 5 आ गया, which is 125. 125 cannot be the remainder. Remainder has to be less than the divisor. तो again divided by 7. तो कितना आता है? 17 7 जा 119. तो I think 6 आएगा आंसर इसका. ये ऑप्शंस आई थिंक गलत हो गए, ये 6 होगा. आई होप हमने कैलकुलेशन तो सब सही किया है, तो ये 6 होगा. 17 7 हो गया, तो 14 आ गया, एक 5, 21 2 5 आ गए, करेक्ट. तो 3 5 आ जाएंगे हमारा यहाँ पे. 125 डिवाइडेड बाय 7, 7 1 जा 7 7 जा 49, रिमाइंडर is 6. Again you see how simple these questions are. If you are enjoying the questions and you are able to understand this concept, so do like the video and do subscribe to the Aptitude Club channel for more such videos. Hit the bell icon also, so whenever a new video comes up you will stay updated. CAT 2023 का अभी मैं session start कर रहा हूँ, so I thought of starting with this unique topic reminders. Gradually I'll go to all other topics and cover everything in detail. You can get all the details in the description of the video also, the Facebook group link, the Telegram group link, and everything. The details you'll get in the description of the video. You can also join me in my live classes on Unacademy. I have posted the Unacademy profile link and everything, so you can join me on the Unacademy platform also if you want to attend my live classes over there. Let's take a look at the final one. 44 to the power 363. Look at the power, big powers, but we'll reduce them by using Fermat's theorem. The purpose of Fermat's theorem reduces the index of the dividend. Yes or no? अभी जितना examples हमने किया, we can see that Fermat's theorem reduces the index of the dividend. So 44 to the power 363 divided by 13 plus 97 to the power 122 divided by 13. Now because the divisor is 13, so that means either 12 or any multiple of 12 अगर power में रहा, so the remainder will be 1. So I'll break it in this way, that it is 44 to the power 360 into 44 to the power 3 divided by 13 plus 97 to the power 120, multiple of 12 में मैं break कर रहा हूँ, into 97 to the power 2 divided by 13. Now here the remainder is 1. 44 divided by 13, remainder is 5. So 5 cube divided by 13 plus remainder of, again here the remainder is 1. 97 divided by 13 is 6. 13 7 is 91. 13 into 7 is 91. तो ये 6 आ गया. So 6 square divided by 13. 5 cube is 125. 13 9s are 117. So 125 117, तो यहाँ पे remainder 8 and 36 13, तो remainder is 10. Remainder 13 to the 26, 36 है तो remainder 10. So overall you get remainder as 18. But 18 can't be the remainder, so you again divide it by 13 and the remainder is 5. Note this, that we are calculating the remainders. Okay, we are not calculating the quotient. The usual result that we have always calculated is the quotient. Division के दो results होते हैं, quotient and the remainder. So we are focusing on the remainder aspect. तो थोड़ा नया लग सकता है for those of you who are just starting and you have no idea about remainders. But still, please don't worry. I am taking very simple, small examples to help you understand this topic better and not take that pressure of like I'm good in quants or not, maths may weak and all. Don't worry about all those things at all. Okay, just watch the videos, try and understand the concepts. I'm taking very simple examples because once that foundation is strong, automatically any difficult question comes, you'll start thinking. But that foundation and that clarity has to be there in the beginning. So hope you found these questions easy, understood how they are solved. And if you have missed the previous session, please watch. I'll also share the link of the previous session in the description and I button पे भी link है. So do watch the first session. This is the second session, and hope all of you enjoyed the session and found some useful insights to think on remainders. We'll continue with more such like concepts and theorems on the remainder series, and other topics के भी sessions चलेंगे in the channel. Hope you guys like the session. So subscribe to my channel if you have watched this so far, and do like and share it with your friends so that the channel grows. So that is it from my end for this session. Thank you all for watching. We'll meet again in the next video. Thank you. Bye bye.